For quiz 2 for math 251. For the first part, we're given this function f of x, this weird discontinuous, maybe piecewise function, and asked to evaluate a bunch of limits. So in this first one, we're asked to figure out what's the limit as x approaches -4 of f of x. It turns out this is undefined. The reason this is undefined is because this is a two-sided limit. It doesn't tell you which side we're approaching -4 from. So you kind of look at it from the left side here, and you say, oh, the height is approaching 3. Then you look at it from the right side and say the height is approaching -2. And so since 3 and -2 differ, this two-sided limit is undefined. Maybe I'll write because the limit as x approaches -4 from the positive side is not the same as the limit as x approaches -4 from the negative side of f of x. But you don't need to write this, just tell me undefined. The limit as x approaches 4 from the negative side, so it's a one-sided limit. Come over here to 4, and it looks like when we're coming from the negative side, so we're coming from the left, so we're talking about walking up this way, we want to know what height are we getting really, really close to. It looks like we're getting close to a height of 2, so limit's equal to 2. The limit as x approaches 4 of f of x. Now it's not telling me from the left side or the right side. It's just saying the limit as x approaches 4. Turns out this is also 2. And the reason why is because the limit as x approaches 4 from the left-hand side is the same as the limit as x approaches 4 from the right-hand side, both of those being equal to 2. The limit as x approaches 2 from the positive side of f of x. Well, let's see, here's where x equals 2, but we're coming from the positive side, so we're kind of way up here, approaching a height of +5. For this answer, it's +5. Limit, finally, last one, as x approaches 2 from the negative side, so that's the same guy, except now we're coming from the left, so our height is getting close to -1. This answer right here would be -1. Okay, state all values of x between -6 and 4.5 for which f of x is discontinuous. So what you do is you look up here and you kind of figure out where the function has holes or jumps in it. Well, it looks like at -4 it jumps, at 2 it jumps, and then at 4 it has a hole. So my answer would be x equals -4, 2, and 4. That's it. All right, moving on to number 2, we're going to deal with limits some more, except now we're going to evaluate them algebraically. So let's see, the limit as x approaches 2 of 2x squared minus 3x minus 2 divided by x minus 2. Well, you could try changing all the x's into 2's, but what you'll see is you end up with 0 over 0. That this, if you think about it as a function, has a hole at x equals 2. It's discontinuous. So we can't evaluate the limit just by changing all the x's into 2's. What we instead have to do is cancel out this x minus 2, because really that's the one that's causing the trouble down here on the bottom. The way we'll cancel it out is by finding an x minus 2 up in the numerator. And the way we'll do that is by factoring. So it turns out that 2x squared minus 3x minus 2 is equal to x minus 2 times, what, 2x plus 1? You can get there a lot of different ways. You can kind of just see that that's the answer. You can say, well, I know there's got to be an x minus 2 there, so put that here, and then work backwards into getting this. Probably the most complete way to do it is, I'll kind of show my work out here. You could factor out 2x squared minus 3x minus 2. Several different ways to do this. Most people learn kind of a guess and check method where they look at this and just come up with the top here. But that's pretty unsatisfying for students, so another method you could do that's a little bit longer but won't involve any guess and check is this 3-step process. The first step is you want to find two numbers that multiply to -4, because that's the product of 2 and -2. So take the coefficient on the x squared term and the constant term and multiply the two of those together. You get -4. The constant term, or the linear term, is -3. So what that means is I need to find two numbers that multiply to -4 and add to -3. Let's see, how about -4 and +1? I think that'll work. Those will multiply to -4 and they'll add to +3. So finding those is step 1. Step 2 is you're going to replace -3x with -4x plus 1x. Why -4x plus 1x? Because those two numbers that I just described are -4 and +1. Now that you have 4 terms, you haven't factored yet, but since you have 4 terms, you can factor by grouping. So look at the first two terms here. Their greatest common factor is 2x. And if you pull out a 2x from the first two terms, you're left with x minus 2. Now what you want to do is look at your next two terms, and you need to leave yourself with x minus 2. So you got to factor out something, and you got to leave yourself with whatever's in these parentheses. I already have an x minus 2, so I can just pull out a positive 1 kind of as a placeholder. Now I have two terms. Here's one of them. Here's the other one. And they both have an x minus 2 in them. So I can factor out that x minus 2, and I'm left with just 2x plus 1. The same thing I got up here. At any rate, maybe this is off to the side. This limit is the same as this limit, and this limit is the same as the limit as x approaches 2 of 2x plus 1. Essentially, because I have the word limit written right here, I can cancel out these x minus 2s. Otherwise, I wouldn't have been able to. This is a limit I can evaluate. This, if you think about it as a function, is continuous. So I can evaluate the limit as x approaches 2 by just changing all the x's into 2's. You get 2 times 2 plus 1. In other words, I'd get 5. Next one. Same basic idea. It'd be nice to change all the x's into 1's, but if you do that, you'll get 0 divided by 0. So all right, I got to get rid of this x minus 1. There must be an x minus 1 in the numerator. It's just kind of hidden. So how am I going to find it? Well, I'm going to take advantage of a little trick we learned where I multiply the numerator and the denominator by the conjugate of the numerator. So instead of the square root of x plus 3 minus 2, like I have written here, I'm going to multiply the top and the bottom by the square root of x plus 3 plus 2. And by carefully choosing the conjugate as the thing I'm multiplying the top and the bottom by, the algebra is going to work out really nicely. Square root of x plus 3 times the square root of x plus 3 is just x plus 3. The outer and the inner terms would cancel out. I'd have 2 square root of x plus 3 minus 2 square root of x plus 3. And then negative 2 times positive 2 is negative 4. Down on the bottom, I'm not going to multiply everything out. And the reason why is because my goal was to get rid of this x minus 1, so I don't want it to be hidden by... It'll be hidden if I FOIL everything out, so leave it all factored so that you can get rid of it. How are you going to get rid of it? Well, note that up top, really all I have is x minus 1. Exactly what I have on the bottom. So I can cancel out those x minus 1's and get that this is equal to the limit as x approaches 1 of 1 divided by the square root of x plus 3 plus 2. This is a limit I can evaluate because this function is continuous at x equals 1. So the way I evaluate this limit is by changing all the x's into 1's, and I get 1 divided by the square root of 4 plus 2, which is 1 divided by 2 plus 2, which is 1/4. Finally, the fraction inside fraction type. Same basic idea. Try changing all the x's into 4's. Won't work. So what you got to do is algebra. To make this one fraction divided by one fraction, I'll get a common denominator in the numerator here. So I'll multiply this by 16 over 16 and this by x squared over x squared, and I'll get 16 minus x squared over 16x squared divided by x minus 4 over 1. What I did is I multiplied this by x squared. It's not true. Multiplied this by 16 and this by 16. I think I'm just making things worse. And I multiplied this by x squared and this by x squared. My purpose in doing that was to get me a common denominator, this 16x squared. And I can do that because if I multiply the top and the bottom of this fraction by x squared, I'm not changing the value of this fraction. Get here. I can evaluate, well, I can simplify this a little bit. Instead of having a fraction divided by a fraction, I can write that as a fraction. Really, instead of using the word fraction, I should be using the word rational expression. Times, I can change this from divided by into times by multiplying by the reciprocal. Instead of x minus 4 over 1, 1 times x minus 4. Remember from the start, this x minus 4 is what was causing trouble. I can't change all the x's into 4's or I'll divide by 0. It's this x minus 4 that I got to get rid of. Hopefully there's an x minus 4 hidden inside 16 minus x squared. Well, in fact, there is. Probably the easiest way to see it is to factor. Note that 16 minus x squared is a difference of squares, so it factors as 4 plus x times 4 minus x. And then you see, oh, I got a 4 minus x here and an x minus 4 here. They're so close. They got to be able to cancel out. Well, they can. They don't just cancel out directly, though. This is the negative of this. So you could say this is the limit as x approaches 4 of, if you pull out a negative 1 from this fraction, you got negative 4 plus x times x minus 4. So this negative I pulled out from this term, and I'm left with this. 16x squared, x minus 4. Now the x minus 4's cancel, and I get this is equal to the limit as x approaches 4 of the negative of 4 plus x divided by 16x squared. I can evaluate this limit. Let's see. Change all the x's into 4's. I get negative 8 divided by whatever 16 times 16 is. This 16 went here. This x squared, when I change the x into a 4, give me another 16. You can figure this out by multiplying together the two 16s, or by kind of canceling. This 16 is 8 times 2, and the 8 cancels with this 8. I'm left with negative 1 over 32. Or by throwing it into a calculator, which is what 90% of the class did, I'm sure. Get this answer. This is the limit. That is the end of this quiz.